Hi everyone. In this video, we'll show a quick way to create and export cameras from RealityScan into RAP, align them with your model, and edit while comparing to the original photos. Let's get started. In RealityScan, I prefer to work with this preset view. First, let's click Folder. Here, we can select the folder with our files and load them into the project. I'll use the original images. We scanned our after and got a set of photos. The photos were captured with 22 cameras. We'll use them to create the scan in one step. For that, let's press Start. We'll need to wait a bit, but it saves time compared to doing it step by step. So let me speed up this process. Now you can see the model with the texture and cameras. The model is not oriented correctly on one axis. Let's rotate it closer to the XYZ orientation. In Scene 3D Tools, I'll choose Set Ground Plane. Now we can rotate the model with the cameras into a more comfortable orientation. I'll press 2 on the numpad to switch to top view. Let's align it more precisely. Okay, now we can set the scale explicitly with markers. I'll set the distances between them. In Image 2D Tools, I'll press Detect Markers. Then, in the side menu that opens, we'll click Detect. Let me speed up this process as well. The program will automatically detect them. Let's click Define Distance, and now I'll set the distance between these markers. In my case, the distance is 0.04 meters. Between these markers, I'll set the distance to 0.02 meters. Here, we'll use the same values. When we set more distances, we make the scale more accurate. So I'll set up the distance for this marker as well. 0.02 meters, 0.04 meters. Let's type in the values for these markers too. Okay, we're done with this part. In alignment, let's click Update. Now we have a new scale. In Scene 3D Tools, I'll also set the reconstruction region. I'll choose Set Region automatically and make it more accurate. Let's export the scan. We can open Mesh Model. Let's click Dense Mesh Model, and I'll use the OBJ format. I'll name the file Neutral Scan. In this window, in the Transformation preset, I'll set it to Maya. This applies a negative 90 degrees on X and Y and scales the model 100 times, so the orientation and scale will be correct in RAP. I'll leave the other settings at default. Let's also export the cameras. Let's open the alignment. In the Export panel, let's press Registration. I'll name the file Cameras. I'll use the internal-external camera parameters, which will allow us to export cameras with distortion. Here, I have rotations on Y and Z at negative 90, and the scale at 100. These are the same values that the Maya preset gave us for the model. Now let's open RAP and check that everything was exported well. We can drag and drop the scan into the Graph panel. I'll drag and drop textures the same way. And here, let's connect it to the scan. I'll disable wireframe and turn off lighting. After exporting, the model stays at the center. Now let's load our cameras. From the list, I'll pick this one as an example. This is how it looks. The CSV format cannot store camera resolutions, so we need to set them. We'll use the same resolution as in the photos. Next, I'll choose the photo for this camera from the photo set. We can drag and drop it into RAP. Then, I'll switch to the 2D viewport. On the image node, we see the picture from the camera. But, like all photos, it has optical distortion. RAP can't render the camera with distortion. For the photo, we add the Undistort image node. Image goes left, camera goes right. This is the photo with distortion, and here's how it looks after correction. Then, we need to use the Undistort camera node. Now let's compare the model with the images. For that, we'll add the render node. I'll connect the model, then the camera. I'll switch between the original image and the render to see the result. Let's double check and look closer. The alignment looks good, so we can switch back to the 3D viewport and continue. We already have the wrapped model, so let's load it. I'll drag and drop the file, and this allows us to compare directly with the scan. The geometry match looks good, so let's see how we can edit the model while comparing it with the photo. We'll do this with the brush node. First goes the wrapped model, then the camera, and the image. Now we'll switch to the visual editor. In the top panel, we can switch to the camera views. Now we see the overlay between the model and the photo. I'll enable the use geodesic distance. Also, let's change the geometry opacity. I'll press X to turn off the wireframe and see the difference. Hotkeys are listed here. The alignment is good, but the left eye needs a few fixes. With the move brush, we can adjust the geometry. You can hold the right mouse button and drag down to reduce the radius. I'll hold the middle mouse button and drag down to reduce the strength. I'll fix the lower eyelid. Here, we'll refine it a bit more. I'll refine the right side of the lower eyelid as well. Now let's adjust the upper eyelid too. Now the model is aligned more closely in the front view, but we need another view to see if it fits well from a different angle. I'll select these nodes. After that, we can copy and paste them. In the Load Image node, I'll choose a photo where the eyes are visible from another angle, in my case, number 13. Next, we'll set the camera to number 13 as well. Let's connect the new nodes. We can switch between camera views with shift space and check the other view. From this angle, we can improve the alignment. Let's do it the same way as before. First, I'll improve the lower eyelid. Okay, now let's refine the upper eyelid as well. I'll switch back and check again. Looks good. Now the model and the photo align more accurately. When the changes are done, let's click Accept. The eye matches the photo now. Using this method, we can fix other parts of the scan as well. That's all for this tutorial. We've learned how to import the cameras from Metashape, align the cameras with the geometry in Wrap, and edit the mesh with the brush node while comparing it to the original photo. Now the geometry matches more closely, and we can continue from here. Thanks for watching, and see you in the next video.